really sorry I can't be there with you today, but at least I can come in virtually. Thanks for the introduction, Amir. I'm going to be talking to you today about the future of conflict. I'm not going to talk about what types of conflicts or anything we have. I'm really going to be focused on the military technical aspects of the ongoing great power competition, really focused on China. It's remarkable to me that our primary competitor, the pacing threat in our national security and national defense strategies, has been so open about his objectives and even his intermediate objectives. For the longest time during our period when our national policy was engagement, Deng Xiaoping said, look, we are going to catch up with the United States. But to do so, what we have to do is hide our strength and our capabilities and bide our time. And that was the Chinese strategy for the longest time. But now under paramount leader Xi Jinping, with a goal of a rejuvenated Chinese nation, he says, look, we're going to be in a protracted ideological and geostrategic struggle over the nature of the international order, which China is unsatisfied with. The ultimate goal, 2049, is to lead the world in terms of composite national strength. In other words, this is code word for knocking the United States off as the dominant world power, replacing it with China, and having China kind of set the rules of the game. He has even set out his intermediate objectives. Made in China 2025 is really focused on reducing China's reliance on foreign technology and making sure that they have their own vibrant innovation base. By 2030, IMF, the International Monetary Fund, projects that China's GDP is going to surpass the U.S. in nominal terms. And they've already surpassed us in terms of purchasing power parity way back in 2014. China Standards 2035, that aims to shape the playing field and landscape for the next-gen technologies by really kind of dominating the global standard-making process. And then, as I said, the goal is 2049. Xi Jinping says, look, hide and bide is past us now. It's now catch up and surpass. So China has the U.S. in its sights, makes no bones about it. It's quite remarkable how open they are, telling the dominant world power, okay, we're coming to get you, and here's how we're going to do it. Now, China, I think everybody knows, is a different type of competitor. Lee Kuan Yew, he's the former Prime Minister of Singapore. This is what he had to say about China. It's just something we always have to be cognizant of. This is the biggest player in the history of the world and is a different type of competitor than the United States has ever faced. So for the next 25 years, I think the real question is, can the U.S. and China avoid what Professor Graham Allison calls the Thucydides trap? It's a metaphor for a dangerous when a rising power like China rivals a ruling power like the United States. And of course, when Thucydides was writing, it was Athens challenging, or it was Sparta challenging Athens, and Germany challenging Britain a century ago. Now, Graham Allison looked at 16 case studies over the last 500 years. And all the reds on the slide, on the right-hand side, resulted in war. So 12 of 16 case studies over the past 500 years, when the rising power challenged the ruling power, the end result was war. Now, you've heard the president and the national security strategy and Secretary Blinken say, look, the next decade is going to be the decisive decade in the long-term strategic competition with China. And I think what they are telling all of us is, we've got to get this right. This is going to take every ounce of our diplomatic strength and every capability in our military toolbox to make sure that we avoid a great power war with the People's Republic of China. I think that's got to be the U.S.'s #1 strategic and defense priority over the next 25 years. Now, avoiding a war is complicated by the fact that, look, we're already shadowboxing. Both of us are preparing for a potential fight. For anyone outside the United States, I would argue that it would look as though we are inching towards a war footing. Now, we're doing it to hedge against a potential 2027 conflict, which is known as the Davidson window. Admiral Davidson was the head of Indo-Pacific Command, and he said, look, we could be in a war over Taiwan as early as 2027. I think you all know our national defense and national security strategy says PRC is the pacing challenge. We're increasing our defense spending. We have the largest defense R&D budget in history. We now have a House Select Committee on strategic competition with China. The CHIPS Act is bringing back chips fabrication into the continental United States. We're trying to secure our supply chains through onshoring and friendshoring. We're increasing munitions production big time. And President Biden, in my view, has abandoned the long policy of strategic ambiguity, where we would say, look, we'll come to the aid of Taiwan, but we didn't say that if China attacks, we will attack China. President Biden has been pretty straightforward and said, if China attacks, we will come to the aid of Taiwan. Meanwhile, in the PRC, this past March, just a month ago, in a series of 4 speeches, President Xi really went out of his way to emphasize war readiness to the country and to his military. He told his generals to dare to fight the United States. He said they were going to accelerate military modernization, intensify civ-mil fusion, meaning making sure that the commercial sector, the commercial innovation sector in China was totally synced up with the military innovation sector. He's establishing national defense mobilization centers. We believe, or at least John Pomfret and Matt Pottinger believe, is a lesson from the war in Ukraine. They're starting to build civil defense shelters and wartime emergency hospitals in the cities across from the Strait of Taiwan. And he reiterated several times that the incorporation of Taiwan is vital to the success of national rejuvenation, which has a time clock of 2049. So everybody knows that Taiwan is the potential spark that could get us into a shooting war, but there might be any other numbers of things. President Obama made sure to say that any Chinese foray into the East China Sea was covered by Article 5. In other words, the United States would come to Japan's assistance. There's, things in South China Sea could go bad. There could be all sorts of different coercion and attacks. The key thing is the next 25 years is really going to be a wild ride. And we have to be prepared both economically, diplomatically, and militarily. So I ask myself, is the U.S. China competition a Kobayashi Maru scenario? Most of you who know me know that I'm a big movie fan. Kobayashi Maru is a scenario or a game that was given to all Starfleet cadets. And it was essentially an impossible scenario. There was no way to win it. And it was really designed to see how the cadets would react more than could they win. So can we extricate ourselves from what I'll call the Thucydides cul-de-sac? And I think everybody knows what a cul-de-sac is, but it's kind of when you're surrounded, further progress is impossible. It's a very, very tough situation to get yourself in, especially if you're a military force. Now, when faced with an unwinnable scenario, James Tiberius Kirk instructs us to change the rules of the game. Eric Schmidt just wrote a very powerful article called Innovation Power in the most recent edition of Foreign Affairs, and I would commend it to you all. And he defines a new force in international politics. He calls it innovation power, which he defines as the ability to invent, adopt, and adapt new technologies. And he asserts or hypothesizes that the ability to innovate faster and better is the foundation upon which military, economic, and cultural power now rests, and it will determine the outcome of the great power competition between the United States and China. Now, both competitors see this the same way. If it's not the central feature of great power competition, it is certainly a central feature. Bill Burns, our director of the CIA, calls it the main arena for competition and rivalry with China. Xi Jinping, look, technological innovation is where it's at. That's where the game is being played, and the competition is going to really get fierce. And Eric Schmidt, again, in his article, says, look, the deciding factor will be innovation power. And he says, he asserts that the technological advances in the next 5 to 10 years are really going to determine the outcome of this 25-year strategic competition. So this next 25 years is going to be a very turbulent strategic and technological milieu. And I asked myself, as a theorist on military revolutions and revolutions in war, is one competitor going to find a recipe for a new military revolution, and through that gain a decided warfighting advantage, which may tilt the competition in their favor? Military revolutions are periods of discontinuous change in the character and conduct of war. The development may be rapid, but it doesn't have to be. It could evolve more gradually before a revolutionary threshold is reached. And that's where we are in artificial intelligence, I think. There's been a gradual development of AI, especially since 2012. And at some point, a revolutionary threshold may be reached by a competitor, and we may all be surprised by it when it happens. Now, revolutionary change, whether it's rapid or evolutionary, is a function of developments in firepower, mobility, protection, sustainment, and command, control, communications, and intelligence. Revolutions have happened in the past when an order of magnitude increase happens in one area, such as the development of atomic weapons. But more typically, it's a synergistic interaction between different ones of these areas. And that's exactly what happened in Blitzkrieg. It had firepower aspects, mobility aspects, sustainment, and C3I aspects. And it led to a new operational concept called Blitzkrieg, which was a revolution in war and gave the German army a tremendous advantage in the first 3 years of World War II. Regardless, again, whether it's rapid or gradual, what has to happen is the capabilities of a competitor have to increase at the strategic or operational level of war to such an extent that they're able to render subordinate or obsolete fundamental aspects of the existing military regime. The existing military regime being the way war is fought by most of the strategic competitors. Now, the existing military regime is guided munitions battle network warfare. It has 2 aspects. Guided munitions. This is a chart that shows the circular error probable between 1944-ish of the weapons that are shot or dropped or propelled fall within a circle with a radius of the circular error probable. So I want you to think about what this chart is telling you. When we were bombing Germany, the gravity bomb CEP was 3,300 feet. In other words, if you dropped 1,000 bombs on Schweinfurt, 500 could be expected to fall within 3,300 feet of the factory, which is more than a half a mile. And the other half wouldn't get any closer than 3,300 feet. Under these conditions, you are as likely to get bombed if you lived near the factory as if you worked in the factory. Now, things started to go down. We would get radar bombing. We'd have all sorts of different weapon systems in the aircraft. And by Vietnam, we could get the CEP down to about 400 feet, which is a tremendous improvement over World War II. But still, if you have a 500-pound bomb, getting within 400 feet of a target is not bad, but it certainly isn't optimal. By the Gulf War, we were using radar-assisted bombing, and we were getting to less than 300 feet. So an order of magnitude improvement since World War II. And you can see now the CEPs are down to 90 feet or less and 45 feet now. And really, it's even more accurate than that. With the joint direct attack munition, which is our standard kind of bomb now, we can get down to less than 20 feet, which is not much more than the length of the bomb itself. So you can see over time the precision of these guided munitions is now approaching, in essence, zero, near zero miss. The red line on the chart shows the percentage of munitions that are guided munitions out of all those expended. In 1965, we weren't using guided munitions very much at all in our air-to-ground campaign. And those that we were using were generally electro-optically guided, and had all sorts of different problems with them. But now you can see we're up near 100%. So really what we're moving towards is 24-hour guided munitions bombardment. And what's important about this is it is a new paradigm. In unguided weapons warfare, the miss distance increases over range. But with guided munitions, accuracy is independent of range. A Tomahawk land attack missile is as accurate at 1,000 nautical miles as it is 100. And this is a true military technical revolution. So not only do you have accuracy independent of range, which means you get an ROI if you use a more expensive guided munition. The most expensive unguided munition in World War II was the V-2 ballistic missile. And its CEP was so big that really it was nothing more than a terror weapon. So the ROI for building this very expensive missile wasn't very big. But now, with Tomahawks being able to hit a target very precisely at 1,000 nautical miles, that gives you an enormous combat capability. Just ask the Ukrainians and how they use HIMARS. Now, the other thing that happens is as the accuracy in CEP in feet goes down, the size of the warhead needed to achieve effects on target goes down too. So what this is telling is, look, if you can get your CEP down to a foot, then the warhead you need is maybe 3 or 4 pounds to really to achieve effects on target, to achieve the effects you're trying to do. This explains, by the way, why drone warfare is becoming so ubiquitous, because drones can now carry a weapon, even though it's maybe only 3 or 4 pound warhead, that really has a lot of capability on the battlefield. Now, to exploit this accuracy independent range, you have to give precision targeting information to the projectile or the munition, and you need a battle network to do that. The first manifestation was the British Homeland Air Defense Network, called the Dowding System, after U. Dowding, who was the head of RAF Command, and it had 4 grids, which are indicated here on the chart. The first was a sensor grid. Had a whole bunch of radars, had a whole bunch of observers, had a whole bunch of height finders. And the sensor grid would provide information to that square box in the middle of the slide on the right, Bentley Priori. And you can see a picture of Bentley Priori. You know, it was a little manpower intensive, but it got the job done. And that is where the commander would make what the commander would call the recognized operational picture. And I just think that is a great term, in that the commander is the one that says, look, there's a whole lot of way to interpret this data, but this is the way I, as the commander, interpret it. It is the recognized operational picture. And oh, everybody else, it's going to be your recognized operational picture too. That information was sent to the effects grid, all of the effectors that would be used in the course of the campaign or battles. In this case, interceptors, barrage balloons, searchlights, anti-aircraft artillery. And then you had a sustainment and regeneration grid, where the enemy is trying to blow up your grid and you're trying to keep it going, or you're trying to keep your effectors in the fight. And you can see here that this was single-seat fighter production, and Fighter Command, RAF Fighter Command, started the Battle of Britain with more airplanes than the Luftwaffe, but they took much more casualties, much more losses early, and so by August 40, they both are about the same number in production. But RAF was able to sustain its losses, make up for its losses, where the Luftwaffe simply couldn't do it. Now, in a mature guided munitions battle network regime, where we find ourselves right now, the future conflict is going to be characterized by what the Chinese refer to as systems confrontation. Think of that as a collision of battle networks. This picture is from a Soviet Navy journal, and then I think it was in the 1986-87 time frame. RUK is the Soviet acronym for Reconnaissance Strike Complex, and they were already saying, this is way back when, these collision of battle networks is going to be what determines the outcome of the campaign. The Chinese see this the same way. The CMC order is the Central Military Commission, and order number 1, this is the guidance from Xi Jinping to his military. You are going to start emphasizing systems confrontation, and you're going to stop worrying about, fighter loss exchange rates over the Taiwan Strait, attrition warfare. You're going to really start thinking about how do you blow apart an adversary's operational system or battle network. And this is the Chinese theory of victory. I think this has been talked about enough where I think most of the people would know this. The Chinese, the PLA, is really into operational systems. They became interested in operational systems after watching the U.S. performance in Desert Storm. And so their theory of victory is you're going to blow apart your adversary's operational system, battle network, or reconnaissance strike complex. So again, the Chinese think less about sinking ships, shooting down aircraft, shooting down ballistic missiles. They're no longer centered on annihilation of the forces to win. It's all about destroying the operational capability of the enemy's battle network. Now, during this emerging period, this is the existing way of war, and it's already changing the way the United States thinks about projecting power. Up until this time, we've essentially had the dominant lead in the guided munitions battle network warfare regime, and it was a tremendous advantage for us. And therefore, we were able to take stuff into theater, build it up, and then start the campaign. But with anti-access area denial networks, we're no longer able to do that. So I asked myself, in the next 25 years, in this era where a military revolution is easy to conceive, how would they come about? Well, there's at least 5 ways. One is the continued maturation of the existing regime. The hider-finder competition is very, very central to the guided munitions battle network regime. If the competition starts to bias towards hiders, you're going to see certain types of military capabilities developed. If they don't, if it biases towards the finders, you're going to see a wholly different kind of development. Within this time frame, space-based targeting, both air and ground, mobile target indicators, along with hypersonics, are probably going to lead to dramatically compressed kill chains. And you could easily foresee that one competitor could excel in system destruction warfare. So any of those things could lead to a new military revolution. In other words, make what we do today either obsolete or subordinate. Another thing that could happen is you could see a war that starts with an initial defeat, and that leads to rapid learning, adaptation, innovation. What we saw in the U.S. Navy in World War II, both in terms of carrier aviation and night fighting. You can see a revolution within the revolution. In fact, I would argue we already see both of these. The chance of space warfare, if war breaks out, I think is very, very high. And we already see how drones are being used on the battlefield, and they will continue to be used in a variety of different ways. Then there is a thing called emergence, where you get this entirely new way of generating combat power. This is what happened with nuclear fission and fusion. And artificial general intelligence is a potential candidate. Now, I think most people do not think AGI is something that's going to happen anytime in the next 25 years. But things are moving so rapidly, it could. And the way Eric Schmidt thinks about it is, look, a breakthrough in AGI for one of the competitors would be just like the period of nuclear superiority in the late 1940s, where it would be a tremendous advantage for one of the competitors. And then we might see a successor revolution occur faster than we expect, and I would refer to that as robotic warfare. Eric Schmidt said it best, I think: if necessity is the mother of invention, war is the midwife of innovation. What I'm trying to say here is the next 25 years not only is going to be a heck of a geostrategic competition, but it's going to be a heck of a military technical competition. And the chances of a military technical revolution, in my view, are quite high. Now, the third offset strategy, and offset X. Offset X is what the Special Competitive Studies Project refers to as what we need to do to try to win the military technical competition. And the assumption for both of those is that the technology to dominate in the next 25 years, to make sure that you do not fall behind in the military competition, is artificial intelligence. Now, AI is a means to a strategic end. It's the key to innovation power. And what innovation power talks about is artificial intelligence supercharges the ability of scientists and engineers to discover even more powerful technologies. They foster advances not only in artificial intelligence, but in other fields. AI is generative in nature, and it presents a platform for continuous scientific and technological innovation, and therefore it could lead to more innovation. On the Bronze Age and the Steel Age, you had to learn how to make bronze, or you weren't in the fight. And in the Steel Age, you had to have the capability to manufacture steel and to put it into different types of systems, or you weren't in the fight. But in this next 25 years, natural resource wealth or mastery of a given technology is not necessarily going to give you the big boost it would have been in the Bronze Age or the Steel Age. The source of the country's power is going to be its ability to continuously innovate. And in this regard, AI is a means to an operational end. A lot of people still talk to me and they say, hey, the third offset was all about AI. And I say, no, it wasn't. It was all about autonomy. AI is the means by which you gain advances in autonomy. So the third offset said, okay, autonomy is coming in two different forms, broadly. The first one is autonomy at rest. That is, virtually through software. It will be manifested in all of the things like intelligent support and predictive maintenance and expert advisory type systems. And because we always thought that autonomy at rest was designed to help humans make better decisions, we described autonomy at rest in terms of human-machine collaboration. Now, DARPA Deep Green was the exemplar of what we were thinking about. This was a DARPA program in the early aughts. It foresaw the commander in the middle of the slide on the right. He would use a tablet, call sketch to decide first. He would say, this is what I'm thinking about, what I want to accomplish on the battlefield. We would turn it over to a artificial, narrow, intelligent, a narrow AI application. It would present options and say, this is what we would foresee as the second order effects. I'm sorry, I'm talking about the AI as though it's a human. Then it would go back to the commander. The commander would take the input from the AI, from the autonomy at rest, and using the same tablet would do sketch to plan. And the whole thing would be to turn sketches and voice, ChatGPT, stuff like that, into a plan description. That would go into a multi-resolution combat model, generate a portfolio of possible futures. You would then update that with the best intel you have, and it would go back to the commander and say, here's the recommendation. The commander would choose among the options and say, okay, this is the plan. And you would write your plans and transmit your plans and execute your plans. The reason why I do this is the Chinese write about Deep Green all the time in their military academic journals. I get the sense that they think we have this. Now, in the early aughts, AI just wasn't to the place where we could make this. But I'd argue we're getting increasingly closer to it, and this would be kind of what you would want to see at the operational level of war and at the tactical level of war down to maybe division, etc. Of course, autonomy would also manifest itself in the physical world through autonomy in motion. And this is going to be intelligent unmanned systems, robots, and weapons. And we referred to this, look, autonomy in motion really is going to work hand in hand with humans to solve complex battlefield problems. And so we refer to this as human-machine combat teaming. Human-machine collaboration are machines helping humans make better decisions. Human-machine combat teaming are machines working in conjunction with humans to achieve combat outcomes. On some specific missions, you would have machine-to-machine combat teaming. You've already seen that now with combat swarms and collaborative weapon attacks. DARPA has a project called CODE, in which all of the incoming munitions and ordnance are talking to each other, and they are coordinating themselves to overwhelm an enemy's defenses. Now, what the third offset hypothesized is, look, what you are going to do is start to see a steady insertion of narrow AI-enabled autonomous applications in each of the grids. Probably what you would see is, okay, Undersecretary of Defense for Intelligence, you are going to be the lead of the cross-functional team for the sensor grid. You will make recommendations on what would be the highest return on investment in terms of narrow AI-enabled autonomous applications. That would go into the deputy's management action group, the DMAC. The deputy would say, so, and you'd start to insert them into the grid. And you do this for all 4 of the grids. And in the meantime, we're building the digital machine-to-machine backbone for joint all-domain command and control. So the expectation was you'd start to insert these narrow AI applications, and at some point, you would reach a tipping point, and you would change the battle network into a human-machine collaborative battle network, and everything would be more rapid sense-making, more rapid sensing, more rapid perception, more rapid development of the operational picture, more rapid development of course of actions and plans, humma. And we said this is going to be the physical manifestation, this new type of battle network that is going to render subordinate or obsolete an old type of battle network that doesn't have autonomy inserted into it. And we call this algorithmic warfare. Now, we just stole from the Chinese definition of intelligentized combat operations. This is the Chinese definition of intelligent combat operations. AI is at the core, with technical support from info networks, big data, cloud computing, the Internet of Things, and intelligent control. Everything is intelligent in the entire battle network. So, the future of conflict, it's the autonomy, stupid. I believe strongly that the widespread application of AI-enabled autonomous systems will increase the quality and speed of decisions, going to enable new missions that we thought were impossible, reduce the number of warfighters in harm's way, and help restore conventional overmatch and strengthen conventional deterrence, and thereby increase the likelihood that we can avoid a war with the People's Republic of China. So, the Kobayashi Maru Scenario, to everyone in the audience and to everyone working with AI-enabled autonomy throughout the Department of Defense: change the rules of the game. Don't accept, hey, this is an impossible mission. It might not be if we can get it right. And if we get it right, I think we trigger a military technical revolution that would give us a decided advantage, and therefore, as I said, lessen the likelihood that we would fight a war with China. Our own Director of National Intelligence said, look, the reason why autonomous systems and AI are going to play a key role is because of their widespread applicability to different functions. And all you have to do is consider the many different ways we're going to talk to you today about how AI and autonomy are going to be used in the future. It's going to affect military readiness. It's going to affect accelerating learning. It's going to improve autonomy both in peacetime and on the battlefield. It's going to be used in cyber defense. These will become ubiquitous, like electricity, and everyone will use them. So I wish I could be there with you today. I'm sorry I'm not, but I'm there in spirit, and I hope that you enjoy the rest of the day, and I hope you learn a lot. This is a competition we have to win, period.